Microsoft Fabric Data Factory Deep Dive. How modern data integration, AI, governance, and OneLake automation come together.
Hello and welcome. In this deep dive, we are exploring Microsoft Fabric Data Factory as the modern data integration and orchestration experience within Microsoft Fabric. Its primary purpose is to help organizations connect distributed data sources, move data at enterprise scale, transform raw information into trusted analytical assets, and automate the workflows that support reporting, analytics, and AI initiatives. Microsoft Documentation positions Fabric Data Factory as a cloud-scale platform for complex ETL and ELT scenarios, but its capabilities extend beyond traditional data movement. It combines low-code development, enterprise orchestration, hybrid and multi-cloud connectivity, AI-assisted authoring, operational monitoring, governance, security, and migration support from Azure Data Factory into a unified Fabric native experience.
The core business challenge Microsoft Fabric Data Factory addresses is that enterprise data environments are highly fragmented and operationally complex. Data may exist across relational databases, files, SaaS platforms, APIs, data lakes, cloud warehouses, operational applications, legacy infrastructure, and on-premises systems distributed across multiple environments. Without an integration platform, organizations often spend excessive time reconciling inconsistent data, managing manual workflows, and resolving duplication instead of generating business value from analytics. Fabric Data Factory helps transform this fragmented landscape into a connected and governed data foundation. It achieves this through scalable connectivity, data movement, transformation, orchestration, monitoring, and automation capabilities integrated directly into the broader Microsoft Fabric platform. Microsoft Fabric Data Factory operates as a core workload within the larger Microsoft Fabric ecosystem rather than as a completely isolated integration product. This means it is deeply connected with OneLake, Lakehouse, Warehouse, Power BI, notebooks, Spark processing, pipelines, governance services, monitoring capabilities, and capacity-based resource management. Unlike traditional architectures that require separate products for ingestion, transformation, orchestration, storage, and reporting, Fabric provides these capabilities within a unified SaaS platform. This integration allows teams to design, move, transform, govern, and analyze data within the same operational environment where business intelligence and AI workloads are executed. As a result, Data Factory becomes a foundational integration layer supporting analytics engineering, BI modernization, data science, real-time analytics, and AI-ready enterprise data products. One of the most important concepts in Microsoft Fabric Data Factory is data integration, which refers to the process of bringing together strategic data from multiple systems into a trusted and usable analytical environment. Effective integration allows organizations to standardize, govern, enrich, and analyze information consistently across departments and workloads. A common integration approach is ETL, which stands for Extract, Transform, and Load. In an ETL process, data is first extracted from operational systems, then transformed through cleansing, shaping, validation, and enrichment steps, before finally being loaded into analytical destinations such as warehouses or lakehouses. ETL is especially useful when organizations need strong control over data quality, compliance, and standardization before information becomes available for reporting or analytics consumption. Microsoft Fabric Data Factory also supports ELT, which stands for Extract, Load, and Transform, as an alternative integration strategy for modern cloud-scale analytics environments. In ELT architectures, raw data is loaded first into scalable storage platforms such as OneLake, and transformation logic is applied afterward using engines such as Spark, SQL, Lakehouse, or Warehouse Compute. This model is particularly effective for large-scale analytics because cloud-native platforms can process large datasets efficiently after ingestion rather than transforming everything before loading. The decision between ETL and ELT depends on factors such as business requirements, performance expectations, governance policies, operational complexity, data freshness requirements, and team expertise. Microsoft Fabric supports both approaches, allowing organizations to combine ETL and ELT patterns depending on the specific workload, operational goals, and architectural strategy. The first major capability of Microsoft Fabric Data Factory is connectivity. Data Factory can connect to cloud systems, on-premises sources, multi-cloud platforms, files, databases, APIs, and SaaS applications. Microsoft documentation highlights support for more than 170 data sources, including hybrid environments that use gateways for secure access. This breadth of connectivity is important because most enterprises operate across a mixed data estate rather than a single modern platform. A strong data integration service must connect to existing systems, legacy platforms, and cloud native services so organizations can modernize without rebuilding every source system first. For on-premises systems, Microsoft Fabric Data Factory can use the on-premises data gateway to securely access internal data sources without directly exposing private networks to the public internet. For Azure data sources protected by private endpoints or private networking, the Virtual Network Data Gateway provides secure connectivity from Fabric into those controlled environments. Service tags and private links can also support secure network design depending on the architecture and supported Fabric configuration. These options help architects balance connectivity, security, compliance, performance, and operational simplicity. The right gateway or private networking approach should be selected based on source location, sensitivity, enterprise policy, and workload requirements. The second major capability of Microsoft Fabric Data Factory is data movement. Fabric Data Factory provides multiple movement patterns, including copy job, copy activity in pipelines, and mirroring. Copy job offers a simplified guided experience for common full, incremental, and change data capture scenarios when supported by the source. Copy activity is used inside pipelines when data movement must be part of a larger workflow with orchestration, validation, branching, or downstream processing. Mirroring creates near real-time replicas of supported operational data into OneLake, reducing hand-built ETL complexity for certain analytic scenarios. These options allow teams to choose the right movement approach based on freshness, complexity, control, and operational requirements. CopyJob is designed as a simplified and guided experience for moving data into Microsoft Fabric destinations. It supports full copy, incremental copy, and change data capture patterns when supported by the source system. A full copy transfers the entire dataset during execution, while incremental copy transfers only newly added or modified data to reduce repeated processing and movement costs. For supported database sources, change data capture can track inserts, updates, and deletes automatically. For file-based ingestion scenarios, incremental behavior can use metadata such as file names, partition structure, or last modified timestamps to avoid repeatedly copying unchanged files into OneLake, Lakehouse, or warehouse destinations. Copy activity, also called copy data activity inside Fabric pipelines, provides more advanced and customizable data movement capabilities. Because it operates within a pipeline workflow, it can be combined with validation steps, branching logic, dependency handling, notifications, notebook execution, SQL scripts, stored procedures, and downstream processing activities. A pipeline might copy data, trigger a Spark notebook for transformation, refresh a semantic model, and then send a Teams or Outlook notification based on success or failure conditions. Copy activity also provides additional configuration options for throughput optimization, fault tolerance, parallel execution, mapping behavior, and operational control. This makes it more suitable for enterprise-grade orchestration scenarios where data movement is only one component of a larger automated workflow. Mirroring is another important data movement and replication capability within Microsoft Fabric. Instead of building and maintaining traditional extraction and ingestion pipelines, mirroring continuously replicates supported operational data sources directly into OneLake with minimal manual ETL management. This allows analytics teams to work with fresher operational data while reducing pipeline complexity and maintenance overhead. Microsoft Fabric supports mirroring for selected platforms and services, including databases and cloud analytics systems supported by Fabric mirroring capabilities at the time of deployment. Because supported sources continue to evolve, organizations should validate current mirroring support through official Microsoft Fabric documentation before architecture planning. Mirroring is not intended to replace every ingestion or transformation workflow, but it is highly effective when the primary goal is near real-time replication with simplified operational management. The third major capability of Microsoft Fabric Data Factory is data transformation. Dataflow Gen2 provides a low-code transformation experience built on Power Query technology, allowing users to prepare and shape data through a visual interface rather than writing code for every operation. It includes a large library of built-in transformations for filtering, joining, aggregating, pivoting, cleansing, enriching, and restructuring datasets from multiple sources. This approach is valuable for analysts, BI engineers, and data professionals who need enterprise-grade transformation capabilities with reduced development complexity. Because Power Query is already widely used across Excel, Power BI, Power Platform, and Dynamics 365, many teams can reuse existing skills and transformation logic within Fabric. Dataflow Gen 2 can load transformed data into Microsoft Fabric destinations such as Lakehouse, Warehouse, and other supported storage and analytics targets. Depending on workload requirements, it can operate using standard compute through the Power Query mashup engine, high-scale compute with staging enabled, and optimized movement scenarios such as fast copy where supported. Recent enhancements improve enterprise readiness by adding capabilities such as schema support in Fabric destinations, public APIs, parameters, CI/CD integration, deployment support, variable libraries, and enhanced query evaluation behavior. These improvements position Dataflow Gen 2 as more than a visual transformation tool. It is evolving into a governed, programmable, and lifecycle-aware transformation platform suitable for modern enterprise analytics architectures. Microsoft Fabric Data Factory also supports code-based and engine-driven transformation through pipeline activities and integrated compute services. Pipelines can orchestrate notebooks, Spark job definitions, SQL scripts, stored procedures, HD Insight activities, and other processing workloads depending on the transformation requirement. This flexibility is important because enterprise-scale transformations often require distributed compute, advanced engineering logic, custom scripting, or optimized processing engines that go beyond low-code tooling. Data engineers can use Spark or SQL for large-scale or performance-sensitive processing, while analysts and BI-focused users can continue using Dataflow Gen 2 for visual transformation scenarios. Fabric Data Factory supports both low-code and code-first development styles within the same orchestration and governance environment. The fourth major capability of Microsoft Fabric Data Factory is orchestration. Pipelines allow organizations to coordinate multiple activities into automated and repeatable workflows that support enterprise-scale data operations. These workflows can execute sequentially, run in parallel, trigger on schedules, or respond to supported events and dependencies. Pipelines support control flow features such as conditions, loops, variables, parameters, branching, retries, and dynamic expressions, enabling teams to build flexible and resilient processes. By combining ingestion, transformation, validation, monitoring, and notification activities into a managed workflow, organizations can turn isolated data tasks into governed operational processes that are easier to monitor, troubleshoot, secure, and optimize over time. Microsoft Fabric Data Factory also supports Apache Airflow integration for organizations that prefer code-first orchestration and workflow as code approaches. Apache Airflow uses directed acyclic graphs, commonly called DAGs, to define task dependencies and workflow execution logic using Python. This approach is especially useful for engineering teams that already use Airflow or require highly customizable orchestration patterns across complex environments. Fabric provides support for Airflow job execution using starter and custom compute pool configurations, allowing organizations to manage orchestration workloads within the Fabric ecosystem instead of maintaining a completely separate orchestration platform. Pricing and operational behavior depend on pool configuration, runtime duration, and resource allocation, making capacity planning important for production Airflow deployments. Copilot introduces AI-assisted development capabilities into Microsoft Fabric Data Factory to help accelerate authoring, learning, and operational productivity. In Dataflow Gen 2, Copilot can help generate transformation logic, create new queries from natural language instructions, summarize applied transformation steps, and explain query behavior. Within pipelines, Copilot can assist with generating workflow structures, building activity logic, creating expressions, summarizing existing pipelines, and helping diagnose or troubleshoot execution errors. These capabilities can reduce development effort and improve accessibility for newer users, especially in repetitive or time-consuming configuration tasks. Copilot generated output should always be reviewed, validated, and tested carefully because AI generated logic may contain inaccuracies, incomplete assumptions, or inefficient implementations. Copilot in the Expression Builder experience is particularly valuable for simplifying complex pipeline development scenarios. Users can describe required logic in plain English and ask Copilot to generate dynamic expressions for parameters, variables, conditional logic, formatting, and runtime evaluation. Copilot can also explain existing expressions, making large or complex workflows easier to understand and maintain across teams. This helps reduce common errors related to string handling, date formatting, variable usage, dependency conditions, and parameter passing. Best practice is to use clear prompts, review generated logic carefully, and validate behavior through testing before deploying to production environments. Copilot improves productivity and accessibility, but reliable enterprise workflows still require strong engineering review, governance, and operational discipline. The Microsoft Fabric Data Factory labs and guided tutorials demonstrate the medallion architecture pattern as a recommended approach for organizing analytical data. In this architecture, the bronze layer stores raw ingested data with minimal modification, the silver layer contains validated and cleansed data prepared for broader use, and the gold layer contains enriched, business-ready datasets optimized for reporting, analytics, and AI workloads. Data quality, standardization, and governance improve progressively as information moves through each layer. This layered structure helps separate raw operational ingestion from curated analytical consumption, improving maintainability and trust in downstream reporting. Microsoft Fabric Data Factory supports this architecture by combining copy job, Dataflow Gen2, pipelines, and Lakehouse storage into integrated end-to-end workflows. The end-to-end tutorial experience in the Microsoft Fabric documentation demonstrates how these components work together in a practical implementation scenario. In the sample workflow, a pipeline first uses data movement capabilities to ingest raw NYC taxi sample data into a bronze Lakehouse table within OneLake storage. Next, Dataflow Gen2 transforms and enriches the ingested data, including combining it with related discount information to produce a curated gold dataset suitable for analytics and reporting. The workflow is then operationalized through orchestration features such as scheduling, monitoring, and notification activities. This example is important because it demonstrates Microsoft Fabric Data Factory as a complete integration and automation platform rather than only a standalone data copy utility. Monitoring and operational visibility are critical for managing production-grade Microsoft Fabric Data Factory workloads. Fabric provides monitoring capabilities for pipeline runs, activity execution details, outputs, failures, retry behavior, and historical execution tracking through the monitoring hub and related operational experiences. Teams can use these tools to identify failed workloads, analyze performance bottlenecks, review dependency execution, and verify successful completion of critical processes. Pipelines can also integrate notification activities such as Teams or Outlook alerts to inform stakeholders about workflow success, failure, or operational exceptions. Effective monitoring transforms data workflows from isolated scripts into observable, supportable, and operationally managed enterprise processes. Pricing in Microsoft Fabric Data Factory is based on fabric capacity consumption rather than traditional fixed infrastructure sizing. Data pipelines consume capacity through two primary meters, orchestration and data movement. Copy activity and copy job consume data movement capacity meters, including separate meters for full copy and incremental copy operations, while orchestration activities consume orchestration capacity. Dataflow Gen2 consumption depends on query execution time, transformation complexity, compute engine usage, staging behavior, and fast copy optimization. Features such as intelligent throughput optimization, fast copy, and virtual network data gateways can increase capacity consumption depending on workload design. OneLake storage consumption is built separately within the broader Microsoft Fabric storage model, so organizations should monitor both compute and storage utilization carefully. The Microsoft Fabric Capacity Metrics app is one of the most important tools for understanding actual workload consumption and estimating operational cost. Pipeline copy activity charges are influenced by execution duration, intelligent throughput optimization settings, and the amount of data processed. Non-copy pipeline activities consume orchestration capacity based on activity execution. Copy job uses different consumption meters for full copy and incremental copy operations. Dataflow Gen2 consumption depends on factors such as query execution duration, transformation complexity, staging configuration, compute engine selection, and whether fast copy optimization is enabled. Because workload concurrency, retries, and gateway uptime settings can significantly affect real consumption, monitoring actual workload behavior through the Fabric Metrics app is more reliable than relying only on theoretical sizing estimates. Gateway architecture can significantly influence operational design and capacity planning. The on-premises data gateway itself does not introduce a separate Microsoft Fabric capacity charge, although organizations remain responsible for the infrastructure where the gateway runs. The virtual network data gateway consumes Fabric capacity based on gateway uptime, configured gateway members, and active workload execution duration. Capacity usage can continue during configured time to live windows after workloads complete in order to support faster reuse and reduce startup latency. Because gateway consumption scales with gateway members and uptime duration, architects should carefully manage gateway scaling, TTL configuration, and workload scheduling to avoid unnecessary capacity consumption. Secure private connectivity through Virtual Network Data Gateway is particularly valuable for enterprise environments using private endpoints and isolated virtual networks. Security guidance for Microsoft Fabric Data Factory begins with strong network protection and controlled connectivity architecture. Organizations should use secure connectivity options such as the on-premises data gateway, virtual network data gateway, Azure Private Link where supported, and Microsoft service tags to reduce unnecessary exposure to public networks. These controls help protect data as it moves between source systems, gateways, Microsoft Fabric services, and destination environments. Network security design should align with enterprise security standards, compliance requirements, and zero trust principles wherever possible. For highly regulated or sensitive workloads, private connectivity, restricted outbound traffic policies, and tightly controlled network boundaries become especially important for protecting data movement and integration operations. Identity and access management are equally critical for securing Microsoft Fabric Data Factory environments and workloads. Organizations should follow least privilege access principles by assigning only the minimum required workspace and data permissions to users, groups, and service identities. Microsoft Entra conditional access and multi-factor authentication should be enforced to strengthen authentication security and reduce unauthorized access risks. Workspace identities and managed identity-based access patterns can help Fabric securely connect to protected resources without exposing embedded credentials in workflows or scripts. Access to shared connections and data sources should also be governed carefully so only authorized users, pipelines, and Fabric items can use approved connections and sensitive data resources. Data protection and governance are important components of a secure and compliant Microsoft Fabric deployment. Microsoft Purview integration enables capabilities such as sensitivity labels, lineage tracking, data discovery, endorsement, and information protection to help organizations classify and govern sensitive data assets. Data loss prevention policies can help identify and reduce risky handling or movement of regulated information across analytics workflows. Azure Key Vault integration and credential management best practices help centralize secret storage instead of embedding usernames, passwords, or keys directly into pipelines and connection definitions. Together, these governance and protection features help organizations understand where data originated, how it is being used, which datasets are trusted, and how sensitive information should be controlled throughout the analytics lifecycle. Backup, recovery, and lifecycle management are essential operational practices for enterprise Microsoft Fabric Data Factory deployments. Git integration can be used to manage pipeline definitions, Dataflow Gen2 assets, and related development artifacts using source control and collaborative workflows. Version control enables teams to track changes, review updates, recover from configuration mistakes, and maintain historical records of development activity. Deployment pipelines and CI/CD practices help organizations promote workloads consistently across development, testing, staging, and production environments while reducing manual deployment risks. Treating Data Factory assets as managed configuration and governed engineering artifacts improves reliability, operational consistency, auditability, and long-term maintainability for enterprise-scale data integration solutions. Migration from Azure Data Factory is an important consideration for organizations already using Microsoft's existing cloud integration platform. Microsoft Fabric provides migration and upgrade guidance that allows organizations to bring Azure Data Factory assets into Fabric workspaces and evaluate compatibility before fully transitioning workloads. Migration planning should include detailed assessment of pipelines, connectors, integration runtimes, activities, security configurations, governance requirements, scheduling behavior, and unsupported or partially supported features. Microsoft also provides assessment and upgrade tooling, including PowerShell-based utilities, to help identify migration gaps and modernization opportunities. The objective should not be limited to simply moving workloads into a new environment, but rather modernizing integration architecture to take advantage of OneLake, unified governance, integrated analytics, and Fabric native orchestration capabilities. Microsoft Fabric Data Factory continues to evolve rapidly with new capabilities focused on automation, scalability, governance, and AI-assisted development. Recent and preview enhancements discussed in Microsoft documentation include Data Factory MCP integration concepts, adaptive performance optimization, Dataflow Gen2, public APIs, AI-powered prompt-based transformation assistance, enhanced schema support for Fabric destinations, advanced destination query editing, gateway automation improvements, and expanded support for incremental copy and change data capture scenarios. Microsoft has also introduced enhancements related to service principal execution, workspace identity integration, notebook execution, and Spark job orchestration. These developments demonstrate Microsoft's broader strategy of making Fabric Data Factory more intelligent, programmable, enterprise-ready, and tightly integrated with AI-driven operational experiences. One of the most important architectural lessons in Microsoft Fabric Data Factory is understanding that each capability is optimized for a different type of workload and operational requirement. Copy job is best suited for guided and simplified data movement scenarios involving full copy, incremental copy, or change data capture patterns. Copy activity inside pipelines is more appropriate when data movement must operate as part of a larger orchestrated workflow with dependencies, notifications, branching, or downstream processing. Dataflow Gen2 is ideal for low-code transformation and Power Query-based shaping, while notebooks, Spark jobs, ITSQL scripts, and stored procedures are better suited for advanced engineering logic and distributed compute processing. Mirroring becomes valuable when supported operational systems can be continuously replicated into one lake with reduced ETL complexity and lower operational overhead. In conclusion, Microsoft Fabric Data Factory serves as the integration and orchestration layer that connects operational systems, analytical platforms, governance services, and AI-ready data products within the Microsoft Fabric ecosystem. It combines connectivity, data movement, transformation, orchestration, monitoring, security, governance, AI-assisted development, and migration support into a unified Fabric native experience. One of its greatest strengths is flexibility, allowing analysts to use low-code tools such as Dataflow Gen2 while enabling engineers to use notebooks, Spark jobs, pipelines, SQL, and orchestration frameworks for more advanced workloads. Organizations that adopt Fabric Data Factory successfully typically focus early on data quality, governance, security, cost visibility, observability, lifecycle management, and operational reliability. Thank you for taking the time to explore this topic, and I hope this deep dive provided a clear, accurate, and practical understanding of Microsoft Fabric Data Factory and its role in modern enterprise data architecture.